the data MDT is used for optimization, right? So if I go show in the global routing to M route, now as you can see, here is technically, this is my type ones, and this multicast group is for VRF cus A. So if I look at VRF, my VRF here for customer A, you can see right here is the default, which is what they're gonna do to join the MDT, which is the multicast distribution tree. And then this is technically what you would call a PMSI, or provider I think it's multicast source interface. Don't quote me on that. I always forget what PMSI is, what the name is. And then this is your data MDT. Now the data MDT is used for optimization, right? Because if you go over a certain threshold, you just don't want to bomb the default MDT. So what would happen is if I go over a threshold, I think this is 10 kilobytes. Once I go over that, everything will switch over to the data MDT, and it'll use a 232.2 something address instead of this multicast address to send the multicast traffic to its peer. So it's kind of an optimization thing. This is why you need to know multicast before you even get into this. So your shared tree is going to be a star comma G. Your source tree is going to be a S comma G, meaning you know what the source is. The only reason why you have a rendezvous point is when you don't know what the source is, right? The rendezvous point is supposed to tell you where it is. So once I start doing the traffic again, or when I'm gonna show you where I send traffic to that IP address, which is this 224, this multicast address. When I get replies, we'll go back and look at the M route table for this VRF, and then you'll see a source comma G.